says, show that 1 minus cosine 2 alpha over sine 2 alpha equals tan alpha. Now, is that trig proof? And the first thing you need to do is you need to know what the double angle formula for sine and cosine are. Because I mean, the left-hand side seems like the one that you could work with best. So we're going to start with the left-hand side. And the first thing we're going to do is we're going to replace sine 2 alpha and cosine 2 alpha in terms of alpha, because the right-hand side is all in terms of alpha. So let's do that. The first thing is sine 2 alpha. Well, there's only one form. It's 2 sine alpha cosine alpha. Now, cosine 2 alpha, there are three forms. One is cos squared minus sine squared, cos squared alpha minus sine squared alpha. And then the other two are 2 cos squared alpha minus 1. And then the other one is 1 minus 2 sine squared alpha. So which one do we pick? Well, what we want to do is we want to simplify it as much as possible. So if you look at the numerator has a 1 minus. So if I do 1 minus this 1 minus 2 sine squared alpha, the 1 will cancel. And that's real good for me because the right hand side doesn't have any numbers. So you want the 1s to cancel. So let's do that. Let's start with the left hand side. 1 minus cosine 2 alpha over sine 2 alpha is equal to 1 minus, and I'm going to put 1 minus 2 sine squared alpha over, and then 2 sine alpha cosine alpha. So the numerator, the 1 minus 1 will cancel, and then it'll just be 2 sine squared alpha over 2 sine alpha cosine alpha. And now the nice thing is this cancels, and then one of this will cancel with this. So you're just left with sine alpha over cosine alpha, which is just tan alpha. And that's the right hand side. So that's the proof. The hardest part is really to figure out which identity for cosine to use. But once you do that, it's just some algebra. And there are a couple of things, if you didn't know, you could just try the different ones and see which one give you an answer. But if you just look at the numerator, that'll also help you figure out and save some time in the exam. Okay. Next question. Solve the equation tan squared x minus tan x equals 0 for x between minus pi and pi. I'm just going to put a red on the line here because this is important when you want to put your solution. The range is not 0 to 2 pi. The range is minus pi to pi. Okay, let's start first by figuring out the solution. So let's say I said y equals tan x. The equation is y squared minus y equals 0. So I can factor this as y times y minus 1 equals 0. That's y equals 0 and y equal 1. But remember now y is tan x, so tan x equals 0 and tan x equal 1. So I'm going to just solve this. I'm actually going to solve it from 0 to 2 pi, and then I'm just going to subtract 2 pi from my answer to make it between 0 and pi. You could do that if you want. And I think it's just easier to do that. Yeah. Okay. So the solution here, the alpha, like the first angle will be alpha equals 0 for this. And then here it'll be alpha equal pi on 4. If you put it in a calculator, you'll see it's well, yeah, it has to be in radians. Keep that in mind, right? But yeah, tan inverse 1 is pi on 4. Because if you remember, well, yeah, tan pi on 4 is 1. Okay, now I'll draw my quadrant. So it's ASTC. Well, for this one, tan is not positive or negative. It's 0 actually. But what you could do is you could just take, okay, this line, and then it's this line. So the two solutions will be here x equals 0 and x equal pi. But then here now, for this one, ASTC, alpha is pi on 4, so that's this. And then the other one, for it to be positive, will be here, this exact same pi on 4. So the solution will be x equal pi over 4, but then pi plus pi on 4. And if you add that, you'll get pi over 4, and then 5 pi over 4. But the last thing to remember is that your solution has to be between minus pi and pi. So I'm going to subtract 2 pi. Anytime you have a trig solution, you could always subtract 2 pi, and it's going to be a solution. So if I do that, I'll get pi over 4. And then here, it'll be minus 3 pi over 4. So these are two solutions, and then this is another solution. The last thing to realize is that pi is not actually a solution because they said not less than or equal to. It has to be less than. So you have to actually throw that away. So the solutions are just x equals 0, pi over 4, and then minus 3 pi over 4 in that particular range. Okay. And yeah, also one other thing is if you just subtract 2 pi from pi, you get minus pi. But they also excluded minus pi. So you have to exclude both of those. That's why pi doesn't become any solution. Okay. I mean, this is a trig problem. You just have to remember like your quadrants and like all this procedure thing. You just make sure you remember how to do it. And they're not gonna kill you, for example, if you left pi in the solution when you're not supposed to. It's not that big of a deal, right? Okay, part C. Let g equal square root 3 cosine theta minus sine theta, and show that g of theta is equal to that, 2 cosine theta plus pi over 6. So how you do this is you say, okay, g of theta is equal to square root 3 cosine theta minus sine theta. Now, one thing I want to really exploit is that they told us what the form of g should be. So you have to remember how to do this first. The first thing is you have to say, oh, it's equal to r cosine theta plus alpha. And I have to find for r and I have to find for alpha. But if you look at what the answer is, it should be really clear to you that r has to be 2 and alpha has to be pi on 6. So when I solve for r, I have to get 2, and when I solve for alpha, I have to get pi on 6, right? So I'm going to use now my double angle formula, angle addition formula for cosines. It's r cosine theta cosine alpha minus sine theta sine alpha. So then here it's r cosine alpha cosine theta minus r sine alpha sine theta, and that's equal to square root 3 cosine theta minus sine theta. So if I look at these and compare the coefficients of, like, for example, cosine theta, the first thing I'll get is that square root 3 should be equal to r cosine alpha. And then the other one is if I look at sine theta, I get that 1 is equal to r sine alpha. So now I'm just going to solve these simultaneously. So this is 1 and this is 2. If I do 1 squared plus 2 squared, well, I get 4 on the left-hand side because square root 3 squared is 3 and 1 squared is 1. And then since cos squared plus sine squared is 1, I get r squared. So I'll take r is equal to 2. For these ones, you could drop the negative. You could always just take the positive solution. So that's not a big deal. And then the last thing is to substitute 1 is equal to 2 sine alpha. So then sine alpha is equal to a half. So then alpha is equal to 30 degrees, or pi on 6. So then putting that back, I get g of theta is equal to 2 cosine theta plus pi on 6, which is the exact form they wanted. And you should know the solution should be 2 for r and pi on 6 for alpha, because they told you that has to be the answer. Okay, the part 2 is now hence or otherwise determine the general solution of g. Now, this is not really a question because they ask you to solve something that's not an equation. Like I just said g, not g equals something. But if you want to solve something, I can't solve x, right? I have to solve like x equal 5 or something like that, So it's not really a question, but what we'll do is, because I want to test your solution, we're just going to solve g of theta equals 0 and find the solution for that. So let's do g of theta equals 0. So I'm going to use the form that I just found, which just says 2 cosine theta plus pi on 6 equals 0. So what I'll do now is let's say alpha equal theta plus pi on 6. I know I just used alpha, but this is a new alpha, right? So just 2 cosine alpha equals 0, or cosine alpha equals 0. And I could just find the general solution for alpha, and then use that to find the general solution for theta. One thing you could do is you could just read off what the solution for, like, you might know what the solution for cosine theta equals 0, the general solution is. But if you don't, how do you do that? The first thing you have to do is you have to find the solutions in 0 to 2 pi. So the solutions in 0 to 2 pi are, if you look at the zeros of course, it's pi on 2 and 3 pi on 2 in 0 to 2 pi. But then the general solution will just be you take the solutions and you just add 2 pi, 2n pi. That'll be pi over 2 plus 2n pi, and then 3 pi over 2 plus 2n pi. And then this is alpha equal all of this. So then the last thing is, this is theta plus pi on 6, so I just subtract, let's do it more clearly. Theta plus pi on 6, that's just alpha, so it's equal to pi on 2 plus 2n pi, or 3 pi over 2 plus 2n pi. So now I just subtract pi over 6, so theta, the general solution will be, I subtract pi on 6, so if I do pi over 6, 2 minus pi over 6, I get pi over 3 here, I think. 3, yeah, and then plus 2n pi, and then this one will be 4 pi over 3 plus 2n pi. So that's how you find the general solution for theta. Now, technically you could combine these two into one if you know the general solution for cosine theta equals 0. The general solution for cosine theta equals 0 is theta is equal to 2n plus 1 times pi over 2. But it's the same thing. You know, these are the exact same thing. You get the exact same thing, except that answer might be a little like more compact because you put both. You know, have a comma here, you wouldn't have a comma because you put both of them into one. But I don't think it matters that much. So I wouldn't bother too much. It's like this one, whichever you feel more comfortable with, I would say. Okay. Part D now is to determine the Cartesian equation of a line whose parametric equations are given by x equals minus 5 minus 60 and y is equal to minus 2 minus 80. So you want the Cartesian equation means you want x in terms of y or y in terms of x. So what I'm going to do is I'm going to eliminate t from this equation. X equals minus 5 minus 60 and y is equal to minus 2 minus 80. Let's say this is 1 and this is 2. So from 1, t will be equal to x plus 5 over minus 6, and then t is also equal to y plus 2 over minus 8. So let's equate the t's, and then I'll get equate t, x plus 5 over minus 6 equals y plus 2 over minus 8. And I'm just going to solve this now. So then I get 8 times x plus 5 equals 6 times y plus 2. And then I'll get 8x plus 40 equals 6y plus 12. And if you want to, let's get y in terms of x, I'll get, well, 6y is equal to 8x plus 28. So then y would be 4 over 3x plus 14 over 3. You know, you could have left it if you wanted in the form from before, but I say just put y in terms of x. That's definitely a Cartesian equation. Okay, and then part E, there are a lot of parts of this question. A plane P passes through A, B, C and they give you the points A, B, and C, and has a normal vector n, which is that. Determine the vector equation of plane P. Now, technically, they gave you a little too much information here because you could find the equation of a plane if they just give you 3 points. Or you could find the equation of the plane if they give you a normal vector and just 1 point even. So if they give you a normal vector and 3 points, that's too much information. But we'll just use we'll just use some of the information and find the equation for P. Because that's all they're really testing. Again, they just want to see, do you know how to do this given this information? So let's do that. And it's a bit, the thing is, you could actually use whichever feature information you like and you'll be able to get the answer. But the easiest one, since it's at the vector equation, I'm going to find the parametric vector equation, and you just have to remember how to do that. So the first thing is you're just going to find, so you'll use the 3 points. The 3 points are A, which is, let's say, minus 3, 2, 1, B, which is 1, 1, 1, and then C, which is minus 2, 0, 1, minus 1. So the first thing is you have to remember what you have, you have to remember the procedure basically, and the way it works is you find what A minus B is basically, or B minus A, let's say. So B minus A is 1 minus minus 3, which is 4, minus 1, 0. You subtract each component. And then C would be C minus A. I'll write that down. Equals, like, for example, be minus 2 minus minus 3, 0 minus 2, and then minus 1 minus 1. So it'll be 5 minus 2 minus 2. And then the parametric or the vector equation for the line, let's say, the vector parametric equation will be, so I take A and then plus a parameter t times B minus A, and then plus another parameter S times C minus A. So to put it all, it'll be minus 3, 2, 1 plus t times 4 minus 1, 0, and then plus S times 5 minus 2, 2. That's a vector parametric equation. Another way you could do it is if you wanted, well, let's just say I want to find the Cartesian equation. I just want to go through how to do that. The way you'll do it is if they give you a normal vector and a point, what you'll say is x, y, z dot product with the normal vector is equal to a dot product with the normal vector. And then I just have to find out what that is. The normal vector is 2, 8 minus 7. So x, y, z dot product 2, 8 minus 7 is equal to, and then a is minus 3, 2, 1, dot product 2, 8, minus 7. So if I do this right hand side, it's going to be minus 6 plus 16 minus 7, which is just 3. And then the left is going to be 2x plus 8y minus 7z equals 3. So it's the Cartesian equation for the line, but they ask for the vector equation, so you should leave it like this.